All right, folks, we're going to do our last presentation of the morning, again focused around the theme of digital engineering. I know several people online and in the room have just heard Dr. Mark Blackburn, but I'll give you a quick introduction in case you just joined us. Mark is a senior research scientist at the Stevens Institute of Technology and a member of the SERC Research Council, where he provides a lot of guidance around systems engineering, management transformation, as well as digital engineering, and Mark's the PI on several SERC tasks, PI meaning principal investigator. Sorry if I'm using an acronym you're not familiar with. Mark's research tends to focus on methods, models, and automated tools for reasoning about complex systems, and Mark's about to talk to you about digital engineering migration of evolved strategic SATCOM system engineering and technical management processes. And Mark, my challenge to you is to make your next research title a little shorter. So over to you.
So I named it exactly as our sponsor named it. How's that? So I stayed true to what they called it, and in some ways, it does actually address this. So yes, we also have Captain Hayes, who's actually on the line. He'll be speaking a little bit at the end. All right. So again, why? Okay. So when we first started to talk to at that time was Lieutenant Colonel Latour, who was actually in some ways moved to another place within Space Force. We were, I guess, finishing up in some ways with our what we were doing with NavAir. And so one of the first things we said is that you need to be able to understand the big picture of digital engineering for program adoption. And they run programs and you know, as Space Force, so you think about what they're doing. And so one of the ones that we're actually working with is for an upcoming kind of a new program. And so we're creating a surrogate. And so what we did is for Space Force, everything is basically it's all, you know, CUI, if you will, District D. And so therefore we couldn't really do that. We actually have tools that are academic licenses. So we created another surrogate called Spacer, which is using the same pattern as we used on the Skyzer. So Skyzer was a search and rescue UAV, and we developed a number of different kinds of models for it. And some of those I'm going to actually talk about. So we actually came up with how to represent the full stack of models from mission to system, as we sort of talked about in the prior talk. But what we're doing now is we're creating a new case study called Spacer, okay, which is using a public domain, you know, and available information. So it's FireSat, CubeSat. And so therefore, we'll be able to share this very easily as unclassified training material for not only for Space Force, but for others, but for also for actually bringing the folks up to speed on this particular pattern that we want for the contractors. So the contractors will be able to see it. They'll be able to see the training material too. We also are investigating how to use the armament interoperability and integration framework and their associated methodologies that we talked about last time, and that's part of our overall digital engineering bootcamp. And so again, we're transitioning this research using Spacer, but also with this digital engineering bootcamp training and an associated workshop, which that's what I'm going to talk about here today. All right, so again, you might have seen this on my last one, but again, we really are tracking what we're doing here. And again, this brings in why model-based systems engineering actually strengthens systems engineering. We're going to bring in OpenMBEE from the NASA JPL because it provides a very good way for us to use a technology in there called DocGen, which allows us to automatically generate documents that can be read in a web browser, so that a lot of the subject matter experts don't need to actually know how to navigate a SysML model, but actually can actually see the information in a web browser. And we've actually come up with a way to create digital sign-offs. And there's other talks on how we've done that, so that these subject matter experts could do the digital sign-offs directly in a web browser, and that information, including the sign-off, can get synchronized back into the actual full stack of models for the authoritative source of truth. So that provides basically a collaboration that actually supports both the decision making, and as you're going to see here, how it actually supports going forward with the interoperability framework. The other thing too is that when we worked with NavAir, we actually went from a process which they refer to as the NavAir systems engineering process model, which actually the NavSim is distro A. It's actually all formalized in terms of a SysML model, but what it also does is it specifies specific artifacts And when you actually have the artifacts, these are things that you can actually associate with the digital sign-off. So they basically are, you might say like, well, show me, the selected operational use case. Well, you put the digital sign-off for basically is the use case approved. And that use case might be represented, say, as a SysML use case diagram. The other thing is, again, we're bringing in the semantic technologies, okay, to actually increase semantic integration, just like we talked about in the prior task. So if you didn't see the other one, the recording is going to be out there. The slides are available. And then again, as we talked, we have done some work in terms of AI, machine learning, and natural language processing, including the work that I had done with Dr. Mark Austin and Dr. Maria. I won't be able to slay her name, but we did how to combine machine learning and artificial intelligence with basically into an architecture to look at digital twins. So those are other reports. That one I'm not going to talk about. But for what we're doing here, the focus has really been on creating Spacer. So Spacer uses the exact same modeling pattern that I'm going to show in a minute to create this authoritative source of truth or authoritative source of information. In my discussion here, you'll see that it's not a single source of truth. Okay, it's a distributed thing that can actually be in various different places, from the mission models to the system models to different contractor models that would be all linked together. And that's the pattern that we want to show. So again, Spacer is based on derived material, and we're actually creating, deep dives. So we're not going to try to build all of the CubeSat, but we're going to do some subset to show how to actually model using this pattern. Again, we're using NavSim, and we're going to also use digital sign-offs. And with NavAir, one of the things about the digital sign-offs is that the gentleman who started the research, Mr. Dave Cohen, who actually saw, I guess, a forum like this back in around 2012, said, I want to eliminate C drills. Well, we didn't really eliminate the C drills. Oh, C drills are contract data requirements lists and data item deliverables. They used to be always produced by paper, and that was the main measure by which someone actually tracked where they're going. But now we've actually shown how we can embed the digital sign-offs directly in the models, and we're planning to do that. And so with Space Force, we are permitted to actually use the OpenMBEE environment that's going to allow us to do that. We do have the full stack of models. We are creating a graphical ConOps. I'll just show you a highlighted picture of it, but we're linking mission models, system models, discipline-specific, and stakeholder analysis models, as we did for NavAir. So this might be including like a cost model. So we did formalize, with the help of NavAir, they created an MBSE model for air vehicle characteristics. And in our Skyzer model actually shows how that actually works. We will also talk about ontology, and it turns out that when we create this CubeSat model for Spacer, it will in some ways be a kind of a reference model. It's a pattern that actually shows both the way to actually build things via the patterns that were recommended, plus actually shows it can be used as a generalization that can be actually transformed for the Space Force folks themselves. And so another thing that was new that we started at NavAir, but we just never got to it, but is really pressing. And I mean, I think Captain Hayes in some ways was, saying that this is what they needed a couple of months ago, is that we're trying to build a digital engineering statement of work. So in other words, what do we actually put in a digital SOW, statement of work, that is actually going to actually tell the contractors what to do? We learned a lot about what can be done, what things are actually subsumed by that. There's a report that was, it's WRT 1001, which Tom McDermott was on with us. If you see Tom, he can actually point you to that. And we actually described the lessons learned and actually trace that to a bunch of measures and metrics that Tom's team actually did analysis on. So that is another thing that actually shows, why we would say, well, we want to be able to actually link your models, the contractor models, to the mission and system models, and I'll show in a second. Again, we demonstrated how to do the art of the possible with Skyzer by modeling everything. Not that everybody would do that, but it turns out that when you do that, some things actually that used to be what NavAir called the systems engineering technical reviews, they were checks. Some things basically were subsumed in either to the method that you were using or the tools that you were using. So some of those actually just go away. And then what we're also doing is that because we actually understood the NavSim method, we're capturing in what's called a Flipbook, which can support training, like every single step along the way that we've been actually doing to actually build Spacer. Right, so here's how to understand what the authoritative source of truth is. This first came from, say, NAVAIR. So we have the full stack of models. So we basically have a mission model. We have the space model, which is really spacer again. We have the ground system models, and then we'll have one or more contractor models. And these things will be decomposed into other kinds of discipline-specific things. And so a key thing here is that this thing that's called the project uses, it's a model input. And so effectively anything that would be changed, say in spacer, the space model, that actually modifies, say, some key performance parameter that's represented as a requirement in the mission model, we'll be able to observe that in the ground system model, and the contractor will be able to see it. That is the notion of being able to see everything as an authoritative source of truth. Yes, we are actually building a graphical ConOp. We use the Unity gaming engine. And when I was actually hearing some of the stuff yesterday, I was thinking that, you know, people should actually do some of this. We have definitely some lessons learned that we did when we've done this 2 different times for the Army. And so I think that this is a new way to think about going to the future, but we've also been able to link our graphical ConOps to our other models using the interoperability framework that we talked about in the prior talk. So, but the idea here is that we're going to build a model that actually uses FireSat, and then so when this is turned over from a training point of view, it should actually apply and actually be used as a reference model, because instead of looking for fires on the ground and being able to do it, the extra Space Force should be able to actually change what they're doing, because actually as they're looking for other things, not just fire on the ground. All right, so how do we do that? So we use a bunch of reference models. And so there's at least 3 types of reference models. One is a process model, which is the NavSem. And so that is how we're building these things to be compliant with that. We also have, say, a stakeholder analysis models. So when we have these other reference models, so for example, what is a reference model? These are things that are described as system models that are derived from other standards, so MIL standards. So for example, the cost model is based off of what's called MIL standard 881F. It basically has a work breakdown structure, and then it covers various kind of things from air vehicles to ground stations. So these are specific generalizations. So these are a superset of everything that might be needed. We had done the same thing for, say, airworthiness, which was dealing with how do you get a flight clearance. We did that for NavAir. So what happens is that you actually create a specific instantiation of the superset, because you may not need every single thing. So you're building these, you're taking the reference model, you're building something else, such as like a capability-based test and evaluation, T&E kind of a model, which we actually did based on a schema that was developed by Mr. Jim Ciarcia, who's from NavAir. And so these are very rigorous, formal kinds of ways to do it. We're also going to be looking at cyber, and there's already a pattern for doing that. And then we're also going to instantiate the cost model. So what happens is that the cost model describes only the things that are related to cost in the context of whatever is in the technical stack. But for example, it could also reference, so if I wanted to change something in spacer, that might change the ground system, and then that could actually possibly cause me to actually need an additional test. Well, it turns out because all these models are linked together, that means that I can actually assess the cost of that in the early going. So in other words, if that change to spacer would change and actually create more tests, it could create more costs, so I can do what-if analysis very early on. And then the other thing we've been able to do is that we're looking at an evaluation model. We actually created evaluation models for NavAir, and it basically is set out to look at basically information that would normally be put out, say, for example, in what was called the infamous section L, which is technical evaluation criteria, and we can actually formalize that using things like parametrics and simulations. But the Space Force also has a number of criteria that they've already developed for assessing contractors. But what's big is that we want to be able to have the contractors build their models so that they can link into this full stack of models. That's going to be the new ask. Okay, so how are we actually explaining the big picture? So that was really what we want to do. So we wanted basically to create this digital engineering bootcamp so that we actually present the big picture of what digital engineering is. Can learn about the various different concepts. So we start very low level, okay, we actually assume that some people are going to be probably stakeholders that are not going to ever model a SysML model. They might be cost specialists that actually can read the models. And so therefore we start with the very basics of the concept of, what models are, what model types are, associated modeling methods that we can use so that they can understand what we mean by this authoritative source of truth and understand how we can go about doing it. And that's why we're actually using the OpenMBEE. And I'll tell you about that in just a second here. So they also need to actually understand the notion of model management, which extends configuration management. That's a very critical term because they have to be able to understand it as if I wanted to make a change, just like that hypothetical change I just talked about. What you would do is you wouldn't just go change the model. No, you need to understand how to do branching, make the change, go back to the subject matter experts, get it signed off, and then merge that information back into the trunk. So therefore, model management is a very important thing. And so it's very important here. So then again, how do we actually use ontologies and semantic technologies to enable the interoperability across these models? Clearly, there's a lot of them that I even just talked about a minute ago that actually need to be done. And we're looking at examples for doing that for our Spacer project. We understand how to use the models to promote better decision-making, just like we showed in the prior talk. Those are exactly the kinds of decision frameworks that we want to apply for the Space Force folks too. And then we want to be able to use those digital engineering tools directly in the class. So for example, we basically have, say, Spacer and Skyzer. They're up on Amazon Web Service. There's a login that can be provided, and we're going to ask people to navigate to different parts of the model. So we would say, for example, well, tell me what the actual cruise speed of Skyzer is. So in other words, we would need to actually navigate to, say, the mission model, to the key performance parameters under the performance requirements to see, that it was actually specified to be 180 knots, things of that nature. And so we're going to show people how to navigate to these various different things that are automatically generated using .gen from the OpenMBE tools. All right, so here in a nutshell, and a little bit of this is potentially changing, but you can see, so we've laid out the various different kind of courses from an overview point of view to the ones that I would consider to be what would be called MBE, which are discipline-specific things, to model-based systems engineering, to understanding, the full stack of models. Here's the section that's really related to the training material that we're doing for the Army. And then we have a few special topics, things, including this digital engineering bootcamp workshop that I'll talk about. And so in here, you can see that we basically look at that there's, training that is actually going to be given, and we're giving it out at the end of November. And we're already running the training for the Army already. But it's like there's introductory courses, and some of those actually have quiz questions, and we'll use the OpenMBE. And then we also have these more advanced topics that can be rolled out later. And so this chart also begins to show you that what are the themes that are covered by these various different kinds of courses. So that's how it's actually laid out. So that's an important kind of thing for people to look at. So for Sandy and Neville, we'll just talk about there's the information, Sandy, and we actually have another write-up on it too. The other thing we wanted to do is that what do we need to do to actually help the Space Force actually deploy all this? Okay, and so while we actually created a Jupyter notebook that actually has a bunch of quiz questions for each of the individual sections, people may not want to actually take that. And so what we decided to do is to create a workshop that actually comes afterwards so that they can actually see what they actually need to actually do. And so this is not fully baked. This is a work in progress right now. But again, it's one of those kind of things where if you don't have someone make something from all the training material that they actually heard, it's not going to be sticky. And so what we wanted people to do is to think about, how would you actually go about doing some of these kind of things on the next program? And so we laid out, and again, the quote nice is plans, are worthless, but planning is everything. And that's exactly what we want to do. So we have a number of these different kinds of things. We're going to create an example that goes through and explains to people, and the answers to almost all these questions are going to be provided in the digital engineering bootcamp. So this includes how to deploy your stuff digitally. Some of that's in the Flipbook, how to actually collaborate, how do you basically decide where do you start? You might want to start with a deep dive rather than going all in for everything. Understanding how you can bring subject matter experts into the fold, and how they can need to be able to read things that are, say, SysML, model-based systems engineering, but they don't necessarily have to write it. Again, the importance of actually understanding how to do model management. And I always explain, I use the word model management as opposed to configuration management. Configuration management is works very well from a, say, from a text point of view. So things that you might have done, say, with software. But when you're actually dealing with models, you basically, if, for example, you actually have a requirement that says that the threshold or the cruise speed, the objective of the cruise speed is 180 knots with a threshold of, like, 10 knots. If something had changed, we want to go specifically and change that one object value and configuration and history. And that's what the difference is when I say model management, and the tools support that. But then how do we do digital sign-offs? Okay. And so really some people have been saying, well, maybe we should just focus on one or more of these topics rather than all of them. But what we want to do is to create a template where we lay this out, have teams of people come in and then take the information away and actually create a plan that will be relevant to how they would actually deploy that on their next program. And then we're looking at other kinds of things that we had started out with, say, like technical progress measures, which is, if you have digital sign-offs, the traditional approach for the way that you would actually do basically progress reporting is very different. And so in other words, you could have a set of digital sign-offs that are completed so that you would actually know that I basically got to the equivalent of, say, my critical design review state. And other things that are related to, like, information rights and things of that nature. All right, so our flipbook, again, it provides a step-by-step guide that we will be providing when we get it actually completed. But it actually goes through every single step to actually create that full stack of model, from how do you actually install OpenMBE, how do you set that up, that's your collaboration platform, why project uses are important, how to use those. And we're going through a step-by-step of the Naviator systems engineering method and documenting that as we go. So that should be provided to the team. So they should be able to say, oh, just follow this as a cookbook. And I have the example, which will be in the OpenMBE, but then I actually have all the models. So a little bit about NavSem, and is that, it was created by a group of individuals. They looked at all the best practices from, and it's still probably being run mostly by Christy Yurko, who's from Naviator, is that it was aligned with these various different kinds of things. They looked at all the best practices of the things that were out there. And so that's why we decided it's as good as anything else to show people how to go about doing methodological development, to be compliant with some kind of method that specifies the process guidelines, but also the actual artifacts that need to be produced. And so, so again, it describes the systems engineering process, the major tasks, basically, hopefully generation of the government engineering plan, and then tries to look at it from a degree of, say, completeness, that's well-formedness with respect to the actual NavSem method, and for this particular spacer model. So what are the steps? Okay, again, it is distro A. It is actually modeled, completely modeled in a set of activity diagrams. And so these are the major steps that it actually goes through. And so we are going to be going through many of these steps, probably mostly down to step number 5, because that's the acquisition part of the step. The rest of the implementation, all those kinds of things, that wasn't actually done from Naviator. So we actually only went down to step 5. So this is like the mission level models, the system level models, the black box for the system, the logical and functional model, and then the physical constraints, which are actually, when we did in Skyzer, we actually simulated the contractor who would actually make the specific decisions about, what particular engine we have, what propulsion systems is used, things of that nature. And so NavSem basically is blown out. And again, here are like the various different kinds of steps that it includes. And so this is what we're actually doing. And then when we use DocGen, you can see that each of those steps has a corresponding element out here in the actual generated model. So this is what it would look like inside of what's called the containment tree. And this is what we're not expecting a lot of subject matter experts to ever need to navigate. But what we would like them to navigate is that this is a screenshot of the actual auto-generated model that came from inside of the model, for at least for the steps 1 and 2. Okay, and so people should be able to learn how to navigate and read it, and that's part of the digital engineering bootcamp too, is to do that. So how does OpenMBE work? Well, it first came around because when it was started, there was challenges in actually doing model management. And so it basically, a lot of the model management was done at the file level, which is not adequate, as I just explained in my particular example. And so, but the other thing what they did is that they created what was called a view and viewpoint hierarchy. It's a thing that gets embedded with the model. So yes, it would be somebody who understands how to model it, but effectively it defines the document structure and the information that needs to get rendered at each of these different parts of the model. And so therefore the subject matter experts should actually participate with the actual modelers to actually come up with the particular view that they would want, and then that can get generated in a web browser that is editable. And the model management inside the web browser allows you to actually trace information that gets modified if you have the rights, because to actually modify something within the web browser. And so, like, why did we use it? Well, okay, so MBSE has been around for 20 years, and I would say that, again, if you go to Tom's McDermott's information, I think it actually shows that it's like it is mature. Okay, the methods are mature, the tools are mature, but in terms of digital engineering transformation, now we have lots of people that are actually making these models. We've heard a lot about from commercial industry too. They're going this way, and so therefore, what do? We basically have to actually help the engineering community, where some of those people are subject matter experts, and so that's why we're trying to do it. And I think that especially when we've been talking to Captain Hayes's group, we can see that there's, there may be as many as, 5, 6 different kind of subject matter experts to every one person that actually would be able to know how to, make a model in, say, like SysML. And so, like I said, there's a lot of these other stakeholder analysis models that we need to also factor into play. All right, so then, so our objectives for using this is just to understand how it works. And there are different kinds of tool proxies. So while you can actually update the view editor, we've also shown for cost models that there's capabilities to actually use Excel as a tool proxy. So Excel is just a way for somebody to actually grab the information in the data, but they would actually push the data that gets synchronized back into the model. So that's, again, we want to emphasize that people need to understand how to actually do model management, because it's going to come into play, both from an OpenMBE point of view, but also from, say, tools such as the Teamwork Cloud, which is used with the No Magic projects that are now been purchased or acquired by 3D Systems. And so then, again, this way we can actually help the subject matter experts to decide where we put the digital sign-offs. They need to understand, and then there's various kind of digital sign-offs. There's, you can have it for 1 person, 2 people. It's template based, so it's very programmable. Here's one example that we did. So we, under NavAir, one thing we simulated was it was the use of it for source selection. Okay, in other words, have the contractor embed what would normally come in as a technical evaluation criteria, which is sometimes done as, say, a spreadsheet in a document called section L. Okay, but what we were able to do is to show that inside of a web browser view here, we can actually have subject matter experts enable it if they actually have approvals to do it, and then they can actually go down and actually set the approvals. And notice you can actually have 1 or more approvals. You can even talk about, different kinds of completeness or risk or other kind of commentary that you would want here. So another question is that, well, if you actually have a digital sign-off, how do we know that it's like if the particular artifact changes? So here is our artifact in this case, the operational use case. We did determine that we can automatically go back and undo a sign-off if we wanted to, and then re-notify the people that the model has actually changed, and you should potentially go back and revisit the sign-off again. All right, so again, coming back to the how well again. So how we're doing? Well, we're transitioning the research, using the SkyZero use case, and I'm very glad that actually we're doing it with publicly available sources. It should be usable by a lot of other parts of the community. Basically, the workforce development is what we're actually focusing on here with these 2 different things. Basically, it's going to recreate another example of NavSim. So I think that adds a lot of value, and it's going to use that modularization pattern that we use for SkyZero. And I think that's a very important one. And I think that we've got a lot of experts that we're working with us at NavAir, and they agree that is actually a very important pattern that establishes that authoritative source of information. Again, OpenMBEE provides the way where we can actually engage subject matter experts now that we actually have a digital engineering transformation underway, And then OpenMBEE is really is the way that we're actually going to be able to use those digital sign-offs. And so again, here's our team over here. It's a smaller team, but again, it builds upon a lot of the people that actually helped us in prior times. And with that, I will open the floor and let Captain Hayes say a couple words if you would like to.
Yes, thank you very much. I think the one thing I really just wanted to add, I guess, Captain Hayes, I'm with the Test Integration Lead for Evolved Strategic SATCOM with Space Systems Command in Los Angeles Air Force Base. And the one thing I really just wanted to add here is how this is applying specifically to our program. So really what it is Dr. Blackburn and her team, they're providing two key components. The first one I kind of think of as the academic theory of digital engineering. And then the second one being, as he talked about, that training for us to be able to understand it. Or simply kind of put, it's they're helping us know what we don't know, basically. So what I mean by that is kind of that academic theory of digital engineering is everything that he just was talking about there. And specifically through their Flipbook approach, we're able to take that, digest it, and then apply it specifically to our program needs. So I think, again, that's a really important, stepping stone of saying this is everything that you need to do to be able to have, a digitally engineered program, and then we can then specifically apply it to Evolve Strategic SATCOM. And the next one they talked about is then that training to understand it, because, we know that we need a trained and equipped workforce in order to operate in this digital vision that we're trying to accomplish. And it's very crucial in what they're doing to be able to have that functional level digital engineering curriculum. But I think what we're really excited about is that spacer approach, because it really provides, that DE sandbox and the hands-on training that he's talking about is really being able to apply this specifically. Like I said, the whole goal is to take this and then somehow apply it specifically to being able to execute a program. So really, bottom line, Dr. Blackburn and the Systems Engineering Research Center team is providing that initial vector that we need as the program office. And then we can take this and then we can run with it and then really, apply it specifically to our current program and any future needs or future programs. So again, we're really excited to have been working with him, and we're excited to continue going with the training and the spacer development. So thank you very much.
Thank you, Captain Hayes. So Nicole, do we have a few times for some questions from the floor or online?
Yep, we're queued up for our first question.
Yes, sir.
Great.
Thank you so much. Scott Thompson from the Cyber Resiliency Office for Weapons Systems. Really want to key in on your talk about the model management and the ability to really to configure and control changes to the model. And your talk about the digital signatures and digital signing of these. So what, not getting too technical in a short amount of time, but how much integrity is in that for the digital signing? I have a lot of concern with the model changing, not be able to get non-repudiation for who made changes to the model, who signed off on the model, and that the model being able to change without being able to detect those changes. So just any insights on how that is done within the model management? Thank you.
Yeah, no, there's like every change. I mean, whether you have a login, okay, and basically you're authenticated on the model management system that would be, say, for example, the Teamwork Cloud. I mean, every change, right down to the exact value that you've changed. So when you log in, those models are, in some ways, that you have to actually be authenticated to basically lock a particular model or branch, or even right down to the node level. So all that kind of stuff is tracked, and there's history that's going on that's associated with that. And there's also, if you actually made, say, if you entered a digital sign-off in, say, the model management system in the view editor, which that's the web browser, it also tracks it. And so then if you wanted to synchronize, and there's a good video, and maybe someone could actually point this out to you, is last year at the doctoral forum for the students, we actually did a presentation and a demonstration of that for the cost modeling. And in there, it talks about digital sign-offs, and it actually shows model management going on. So if there's a video, there's also a number of short videos on Dr. Hutchinson, Nicole, she could actually point you to some we worked on digital sign-offs for her talk that's coming up, I think, on DECF, which is the Digital Engineering Competency Framework. So yes, we can do it all the way down, right down to the very low level. And if you entered a digital sign-off, we can track who actually made the sign-off.
Thank you very much. Looking for other questions from the floor, but also, Mark, we had a quick question online, which was, is this training going to be available only through ESS, the Bootcamp I'm referring to specifically? Will it be more broadly available to the Space Force, or is there a larger scope? I think there's basically interest in taking your Bootcamp.
Yes, actually, so it turns out that Captain Hayes connected us with the people that are actually doing workforce development at Space Force. And so they are actually looking over what we're doing, and we're looking for feedback from them. But yes, I think they plan to use it more generally. We want to spread the news. It's like, this isn't specifically for just Captain Hayes's project. This is definitely for others. And we've invited the Army to actually attend too. They might actually send a couple of folks too. But I know that it's like, I think Dinesh has wanted this, Dr. Verma has wanted this for a long time.
Yeah, just to add on to that, specifically, if you're tracking the Space Systems Command Digital Engineering line of efforts, it's line of effort number 5, which is the training, and that is SSCS1 is taking the lead on that. But yeah, the idea is it's going to be opened up to a lot more people. Thank you.
And it should be.
Hi, Mark. This is Steph Chiesi, a SERC doctoral fellow over at Stevens. Question which relates to, I think, even the earlier question. As you're looking into this for the sign-off into using MMS with OpenMBEE, have you done anything yet that looks at it for federated systems? So systems where you've got, or systems of systems, where you have either multiple customers, multiple suppliers, people who are used to being perhaps competimates, where you definitely have intellectual property that's in different types of authoritative sources of truth that could be based on either company or those types of boundaries. How have you looked at that yet, or are you going to? Or
No. So yeah, so we haven't, but actually I think that the Space Force is going to be one of the first times that we're going to get to do that, because they really, and I can't really talk very much about it, maybe the captain could, but it's like these two contractors, we know that there's going to be two contractors, and why we're trying to make the digital engineering SOW to actually have people build stuff like this is so that they can come back and actually link their information in for however they're going to refine what they're doing. And so we haven't actually done that. I'm not sure that we'll ever be able to see that, because whatever the contractors do, it'll be CUI. So the best we would actually do is to simulate it. Now, in terms of going low level, in terms of like going to deep low level analysis that would actually be potentially done in the way a contractor would do it, that is one benefit of actually our work with the Army, and that is because the Army is a little bit different. So like normally NavAir and say Space Force, they would stop at this level here. As you know, as I was sort of saying, NavSem step number 5, and then they would actually let the contractors do the rest. But the Army is different, basically because they actually have to build prototypes. So we go all the way down to the very low level kind of analysis, but we actually haven't trying to actually think about it as a simulated contractor. So I think it's a good thing to think about. I think that's why I think that it would actually apply as much to the ERIC stuff as we saw, because it's an acquisition kind of a thing. And I think I've emphasized that with Dr. Verma before, that I think that applying some of this stuff and actually bringing in the ERIC kind of perspective, as you know, at this time is almost like where we need to go. But thanks for the question.
Looking at Stephanie, we're good? Yeah, okay, she's good. Our final question comes from the virtual audience. And so you shared the example of signing off in the model. Can digital sign off extend to system acceptance and possibly tap on digital twins of fielded systems as well?
Yeah, I see no reason why it couldn't. It's basically, it's like, it's a sign off. It's a block that gets put into, into the model and says that I'm going to associate this particular sign off with this kind of evidence that needs to be done. And so, yes, I could see looking at sign offs of tests or all these other kind of things that would actually just, it mirrors in some ways, I suppose, the more of the structure that we have for our interoperability and integration framework. So I would absolutely say yes.
Thank you very much. Please join me in thanking Dr. Blackburn for his talk. This concludes the morning tracks. Please head outside the room if you're here with us in DC. Get your lunch, and our keynote will resume at 1:15.